as we continue to proceed to our end goal of solving log equations, we need to learn how to either condense them or expand them. In other words, try to make it simpler to solve an equation. So there are some situations when we have to smush two different logs together. There are some situations when we have to break them apart in order to solve an equation. So today, our focus is not on solving. Our focus is just on rewriting. And so our central question reflects that. How do we simplify logarithmic expressions? And with our objectives, we're looking to do three different things. First, I want to expand logs, so make them bigger, break them into pieces. Then I want to condense them, so smush them together, make them simpler. And finally, I want to utilize the change of base rule to evaluate logs. And all of those processes will be part of our solving tomorrow. So make sure that you're okay with how the rules function. As we talk about expanding and condensing, there are three rules that we typically use. The first one is if we have a product inside of that logarithm. And what we're able to do is rewrite this as log base A of A. And notice that that multiplication becomes addition. And this is log base A of B. So things that I want to point out, that log base, that A here, notice that A stays the same throughout. It doesn't change, it doesn't get split up, that stays consistent. Also, that multiplication and addition, those two go together, so when I break it apart, multiplication and addition go together, just like in number 2, division and subtraction will go together. So when I refer to the second rule, again, I'm looking at that division sign, and when I split this up, it becomes log base A of A. Division goes to subtraction, and it becomes log base A of A minus log base A of B. And last but not least, we have a power rule. So if I have an exponent, I can kick this to the front, and this becomes C times log base A of A. And that's probably going to be the most helpful for us because there's a lot of times when A to that power of C will give us a large number that we don't know how to deal with. If we move it to the front, it makes it a little bit more easy to handle. So those are the three rules that you're going to be using consistently today and tomorrow when we solve. So make sure that as we're going through examples, you don't necessarily need to know which rule is being used when, but you have to be able to apply them. One point of caution before we get started, this is a very common mistake that I see. This scenario right here, that is not equivalent, and that's why I'm going to highlight this guy. Those are not equal, and the reason why is only the b is raised to the c power. So for me to rewrite this, if I had log base a of ab all to the c, what I would have to do, since there's multiplication here, my first step would be splitting this up. So I can rewrite this as log base a of a plus log base a of b, all raised to the c power. And then I could take that c and write it out front. And so this would give me log base a of a plus c times log base a of b. And so if you can see, this is not equivalent to this. So that's a very different scenario. Now, in the second example, when we have log base ab to the c, this c can be distributed to both, so it does equal the second set. So I just want you aware of that little subtle difference. If you're going to move an exponent to the front, make sure that everything is raised to that same power. Usually, starting with numbers is a little bit more effective because you are more familiar with how they work, so that's where we're going to begin. Please resist the urge to just plug this in a calculator. I know that it will simplify very easily in a calculator, but I want to work on the rules, not necessarily the answers here. So my first step in this situation would be to see what I want to do. And in this example, I have subtraction, so I would want to smush it together by using division. And so this would be rule 2 on the previous page. So that subtraction can make us rewrite this as, okay, log base 2 of 160 over 5. So we can take that, that multiple logarithmic setup that's on the left-hand side and smush together or condense it into what we have now. Still want to reduce this, still want to evaluate it, so this becomes log base 2 of 32. And evaluating that process, remember this is something that we would have done from the previous lesson. And so I would say, okay, log base 2 of 32 equals x, which allows me to rewrite this as 2 to the x power equals 32. So I need to think about what powers of 2 there are. So 2 squared, 2 cubed, 2 to the 4th is 16. So we're looking at x equals 5 here. And so this simplifies or evaluates into 5. Moving on. Now we're looking at a problem where it's already condensed, so I want to expand it. I want to break it into pieces. So in this example, we have division. So when we split it up, I need to split it up using subtraction. So we can rewrite this as log. If you want to use base 10 here, you can. I'm assuming that you know that this is a common logarithm, so the base is 10. So this becomes log of 1. It's division, so we're subtracting, minus log of the square root of 1,000. Okay, so now we're going to continue splitting this up. Rules that we know from previous lessons, hopefully, looking at what's here. Log of 1 equals log base 10 of 1, which is if I set that equal to x, 10 to the x equals 1, or more appropriately, x equals 0. So this becomes 0. That's also a rule that we had on a previous day. In the second example here, this guy, this becomes log base 10 of 1,000 to the 1/2. Remember, the square root is the same as the 1/2 power. That now allows me to kick it out front, and it's 1/2 times log base 10 of 1,000. And so I'm looking at this thinking, okay, 10 to what power equals 1,000? In this case, 10 squared would be 100, so 10 cubed would be 1,000. So this becomes 1/2 times 3, or 3 over 2. And so this is really just 0 minus 3 over 2, or more appropriately, negative 3 over 2. So things that you're going to have to, or I'm expecting you to be able to do, you still need to know your powers. You still need to be able to bounce back and forth between radical form and exponential form. So that's where that square root to the 1/2 became used. And then last but not least, we have to know how logarithms and their properties work. So these two are problems that I would expect you to be able to do without the help of the calculator. Same thing with number 3. We initially get intimidated by 8 to the 33rd power. There's no way you know what that is. If you do, awesome. But my guess is you're not comfortable with that power. What I would expect you to do is kick this out front. And so this becomes 33 times log base 2 of 8. And if you're still setting it up, that's fine. If you know that log base 2 of 8 is 3, that's okay too. But here's your thought process. Log base 2 of 8 equals x. 2 to the x equals 8. So x has to be 3. And so really this becomes 33 times 3, or 99. And then last but not least, these are the fun ones. Anytime you have a natural log and an e, they will always cancel each other because they are inverse functions. And so in this case, those two cancel each other, which leaves us with the natural log of e to the 200. Another round, natural log and e cancel each other, which leaves us with just 200. So try not to overthink the natural log and e. If you see those next to one another, just remember that they will always cancel. Okay, so as we are starting to move on, we're going to go to examples that you cannot do in your head or that have variables in there. So as we go through these, make sure that here's my recommendation would be pause the video, try it on your own, then check your answer with mine. If you're good, then awesome, proceed as usual. If you're not, then listen to the explanation. So here we go. If I'm looking at log base 6 of the 4th root of 17, my first step would be to get rid of the 4th root. And the reason why you guys typically don't think about numbers as in radicals, and in this example, there is no perfect 4th root of 17. So our first step would be to rewrite this as log base 6 of 17, all raised to the 1/4 power. And just a reminder that 1/4 power is coming from this. 17 to the 1st is what's there. And so the 1/4 is derived from the power on the 17 and the index of the radical. When we're here, now we can kick this to the front. And that allows us to say 1/4 times log base 6 of 17. So that's us expanding it as much as possible. There's nothing else that we can do with it. And for right now, the only thing that I want you to do is leave no exponents in your final answers, if that's possible. And in this case, there's no exponents. I'm not looking for you to evaluate log base 6 of 17. If you know how, good for you. We're not quite there yet. Okay, so we're jumping from numbers now into variables. And when we have this, log base 7 of the square root of x squared minus 9. Please avoid this. You cannot just go, okay, the square root of x squared is x, and the square root of 9 is 3, so this becomes log base 7 of x minus 3. Yeah, it doesn't work like that. So avoid the temptation just to start massively canceling each other out. You always want to start on that innermost piece of the logarithm. In this case, the square root of x squared minus 9. So I'm looking at the x squared minus 9 piece. Try to factor first. And if we're able to do that, we can rewrite this as log base 7. We still have the square root there. But x squared minus 9 will factor into x plus 3, x minus 3, the good old difference of squares. Now we're here, we can rewrite that square root, and we can write this as log base 7 of, we still have the x plus 3, x minus 3. But now we can say it's raised to the 1/2 power. Again, that square root is what's making us rewrite that as the 1/2 power. If I have a 1/2 power there, I can write that all the way out front. So now I'm kicking this to the front of my expression. And it's 1/2 times log base 7 of x plus 3, and I'm going to make this a little bit more obvious, times x minus 3. And the reason I wanted to write that there is I want you to see that product rule and see that we can use now addition to subtract by two logarithms. So now rewriting this, the 1/2 is still all the way in the front, but we can split this up into two logarithms, log base 7 of x plus 3 plus log base 7 of x minus 3. I'm okay if you leave it there. If you really are feeling so inclined, you can distribute that 1/2 through, and we can write this as 1/2 log base 7 of x plus 3 plus 1/2 log base 7 of x minus 3. If you want to take that one step, you can, but both are okay. When we start introducing variables, that's where everything becomes a little bit more convoluted, more complicated, but that is what allows us to eventually solve equations. So that's where we're going to continue next. Okay, so now we're specifically looking at just expanding. So I want to break this logarithm that we're given, the log base 4 of 7 divided by 4 times a to the 5th. I want to break that up into pieces, and I want to break it up as much as possible. Again, I know I'm done when I have no exponents anywhere. In number 7, we can rewrite this as there's a division sign here, and there's a multiplication sign there. So we can rewrite this as log base 4 of 7 minus, this is where it gets a little tricky. We have log base 4 of 4. The time sign goes to a plus, and this is log base 4 of a to the 5th. Now, what I wrote is incorrect, and I want to emphasize why. There are two things on the denominator. We have a 4 and we have an a to the 5th. So if you want to write it like I have, you're going to need parentheses here, because technically both of those pieces are being separated by the division. So we're subtracting both of those. So our options are writing it like I have, or if you want to get rid of the parentheses, you can also rewrite it like this, minus and minus. So whatever method that you use is okay with me, but just know that because both of those pieces are in the denominator, we're subtracting each side, or each value. Personally, I like the first way of writing it better. It just looks a little bit cleaner to me. So yes, we are subtracting. Yes, we are adding. But we're subtracting both of those pieces because they're both on the denominator. The good thing is, no matter what way you approach it, you're still going to end up with the correct answer, the same thing that I end up getting. So if you want to do it your way, that's perfectly okay. Canceling and simplifying, that 5 is going to be moved in the front. And we also have a log base 4 of 4. So what's going on here is you're writing log base 4 of 4 equals x. 4 to the x equals 4, so x equals 1. So we can rewrite all of this as log base 4 of 7 minus 1 plus 5 times log base 4 of a. Okay, and a couple things I want to talk about. I know that I can simplify that log base 4 of 4 because I see a power of my base. In other words, 4 to the first power is 4, so I see a relationship between those two. I know I cannot simplify these because there's no power of 4 that equals 7. So just a little step so you know when you can simplify, when you can't. I do want to tidy this up a little bit, so at this point I would probably want to distribute that negative through. And this allows me to rewrite it as log base 4 of 7 minus 1 minus 5 log base 4 of a. And that's how I'd want you to leave it. So just make sure that you know that that's distributing, that negative is distributing through. Typically what we struggle with most in these is when we have like fifth roots, fourth roots, cube roots, all that stuff. So that's going to be our next focus. And using our natural log, remember that this is the same as log base e, but it's just a shortcut of writing it. First thing that I'm going to do is highlight a few things. First, I see a fifth root, and I also see a division sign. So that's going to help me with my first step. So we're going to rewrite this as, not log, let's go natural log, of the fifth root of AB. Division means subtraction, so this becomes the natural log of c to the 2/3. Now that fifth root can be rewritten as the natural log of AB all to the 1/5. So that's my like first step, if you will. Now a few things that we're going to do. In both of these situations, I want to kick the exponent to the front. And so this becomes 1/5 natural log of AB minus 2/3 natural log of C. This for continuity. I'm going to write parentheses there too. You don't need them. Okay, the next thing I'm going to notice is I have a multiplication in between that A and the B, so I can split those up using addition. And so the 1/5 is still on the outside. And this becomes natural log of A plus natural log of B. And we still have that minus 2/3 natural log of C. Last step, again, I would probably accept this, but I also want to distribute that 1/5 through because sometimes we're going to need to do that in order to simplify. And this would become 1/5 natural log of A plus 1/5 natural log of B. And we still have that minus 2/3 natural log of C. And again, we would stop there. I get on these that we're not really solving for anything. We're just practicing the skills that we need in order to solve tomorrow. So kind of bear with me. My focus for today is just getting good at all of the rules. And so it might seem like, okay, we're not really doing a whole lot, and I would agree with you. But all of these things are going to be implemented tomorrow as well. So I need you to be good at kind of manipulating logarithms and doing what you need to do. So in all of these examples, we're making things bigger, we're expanding them. In the next couple, we're going to go the opposite directions and condense. So when we're looking at this, I'm trying to take it from 2 logs into a single log. And here's how we would do this. We'd first go, okay, there's subtraction. And so if we're looking at this, it becomes log. Remember, this is log base 10. It's a common log if it's not written. Just a heads up. Ooh, there we go. And so if I wanted to rewrite this, this becomes log of the x squared minus 4 goes in the numerator, and the x minus 2 goes in the denominator because that's what's subtracted. And we're here. At this point, I would want you to see that the numerator, there is a difference of squares, so we can now factor the numerator. So this becomes log of x plus 2, x minus 2, all over x minus 2. And because we have a repeat factor in the numerator and the denominator, those will cancel. And we are left with log of x plus 2. And so in that example, I hope you can start to see, okay, here's how I'm going to smush things together in order to make them cancel, eventually making me solve something. Because what we're going to do tomorrow is set this equal to a number, for example. And then from there, we would go through and solve. But again, my focus is the rules today, so that way we can use them successfully tomorrow. So that's an example of condensing again. So you can take a look at number 10 and see there's a lot of stuff going on. And so I want to take this and smush it as much as possible. So things that I'm noticing here, we have subtraction, which means that this is going to be in the denominator. We have addition, which means that this is going to be in the numerator. And we have subtraction again. So again, that's in the denominator. So what we do, and we're going to kind of do a few things at once. I'm going to take any exponent or any number that's in front, any coefficient, and move it up to the exponent first. So that's going to be my first step. So that's going to be kicked up, and that's going to be kicked up. And again, since this one is positive, it's in the numerator as well. So my first step is going to be rewriting this as, okay, log base 5 of a cubed minus log base 5 of b plus log base 5 of c to the 1/4, and minus 6 log base 5 of a squared, all raised to the 6th. Okay. The reason I do that is I want to try to reduce the clutter as much as possible. Again, highlighting these. That's in the numerator. That's in the numerator because those are both positive. In the denominator because they're both subtracted. And so when I write this as a single logarithm, it's going to be log base 5, and I'm going to write all of this in a fraction. Okay, and so here's what I'm looking at. That a cubed is in the numerator, as is the c to the 4th. And now it's multiplication because they were added, and so to squish them together, I have to use multiplication. The red, that's what's subtracted, that's in the denominator. So a few things that are happening. Yes, we're going to have a b here, and we're going to have an a to the 12th. Remember our rules of exponents. If I have a power to a power, those multiply. And so this is where I'm starting. Also, a few things. I would need to simplify this. I don't want to write 1/4 as a power. I want to write that as a radical. And we also have exponents with common bases, and we're dividing, so we can subtract those. And so what we're able to do in kind of one fell swoop is rewrite this as a log base 5 of, that c to the 1/4 becomes 4th root of c. If I subtract my a's, I move those 3 a's to the bottom, and it becomes a to the 9th on the bottom. And then we have that b attached as well. And so again, that c to the 1/4 became the 4th root of c, and that a cubed over a to the 12th became a to the 9th. It's written as a single logarithm. We have no coefficients in front of my final answers. In other words, there's no number in front of my logarithm there, and so we know that we're done. Okay, a couple more. First thing that I want to do, just like last time, I want to kick this to the top. And so we can rewrite all that mess as log of 12 plus log of 7 to the 1/2 minus log of 2. That's subtraction, so it's in the denominator. That's addition, so it's in the numerator. So when we write this as a single log, it becomes log of 12 times 7 to the 1/2 is in the numerator, and 2 is in the denominator. Simplify this now. We're looking at it going, okay, we have 12 in the numerator, 2 in the denominator. That reduces it to 6. Also, 7 to the 1/2 can be rewritten as the square root of 7. So now we can rewrite this as log of, again, 12 over 2 is 6, and this becomes square root of 7. So just so you can see where pieces are coming together. If we're struggling with making the 7 to the 1/2 equal the square root of 7, just a quick little reminder, things like this, let's go 2 to the 2/3. That can be rewritten as the cube root of 2 squared. So you can see where different pieces are going. The numerator and the denominator goes in front. And that's always going to be the case. So in this case, 7 to the 1 went on the 7, and the square is the index in front, but we just don't write those two typically. So if that's a reminder, good. If that seems like new information, that might be a conversation piece that you and I have tomorrow in class. And last example with variables. Okay, so we have now all variables, kicking that c to the top and that r to the exponent. We can rewrite this entire mess as log base a of b plus log base a of d to the c power minus log base a of s to the r. And generally, this is why this is the last example. I want to make this as annoying as possible. And if you're able to reason through with all variables, there's not an example that I can give you that is going to throw you for a loop. So if you're okay on this one, typically you're going to be okay on any problem that I give you. Before we continue on this, I do want to point out that if I were to have a different base, for example, if this would have been log base b, I can no longer combine it. So I have to have the same base in all my logarithms in order to make them squish together. Okay. Now that we have this set up, that's addition, so it's in the numerator. That's subtraction, so it's in the denominator. So as we rewrite this, it becomes log base a of, we have b times d to the c, that's my numerator, and we have s to the r in the denominator, and that's as much as we can do. And I'm not sure why I wrote 2, but that is s to the r. There we go. Okay, so as you're going through, if this one threw you for a loop, that's okay. We can talk through it tomorrow. But I did want to point out very briefly, change of base formula. Depending on what calculator you have, you're going to use this exclusively or not at all. If you have an 84 plus, you're going to use alpha window 5 to evaluate logarithms. If you have an 83 or a Casio, you have to use change of base. And so here's how this works. Looking at log base 5 of 8, to evaluate what this is, you would have to type the following in the calculator. Log of 8 divided by log of 5. And the way that I remember it, the base is on the bottom. And so you would plug and chug this into a calculator. You would plug this into a calculator, and you would end up getting 1.292. So here's what I would ask you to do. If you have an 84 and 84 plus, make sure that you can end up with 1.292 using your way. If you have an 83 or a Casio, make sure that you know how to use the change of base formula. What I would caution you, if you are using the change of base formula, make sure that you have parentheses in the numerator and parentheses in the denominator. That's what's going to make the big difference. Again, if you end up getting 1.292, awesome, we can kind of proceed business as usual tomorrow. If you struggle with that, make that the first thing that you ask me. That way we don't waste time in class tomorrow. Homework is listed below on page 373. As always, I'm available for help.